Hi, in this video I will solve problems related with cubic planes which was in your assignment. So first, here the planes are given. This plane goes through the origin, which is here. We had a rule that if planes goes through the origin, we have to change the origin. So I will choose this point as an origin. Why this point? If you see, this is negative y-axis, this is negative x-axis, and if I draw z-axis, this plane actually comes outside of the cube like this and intersects z-axis somewhere here. So that is the reason why I have chosen this point as an origin. I see that if I choose this part as an origin and if I draw axis system, this plane will intersect x, y, z axis at some point. That's why. So for this one, if it is difficult for you to imagine how this intersection takes place over here, let me draw this. This is a plane and this is z-axis. So z-axis intersects plane over here and goes outside of the plane. It's difficult to see over here, but it is as I said. So what I will do, I will try to find intersection points. So x, y, z. It's clear that this plane intersects y-axis at -1/2. Plane intersects x-axis at -1. So trick one is to find intersection between plane and z-axis. In order to do this, first I will derive equation for plane and later try to find where that plane intersects z-axis. In order to do this, first I will mark points. This is point 1, point 2, and point 3. Now I will find point coordinates for 3 points of the plane. Point 1, which is here. Keep in mind I have changed the origin. Now this is the origin. According to this origin, what's point coordinates of point 1? In order to go there, I need to move -1 in y-axis, -1 in x-axis, and -1 in z-axis. So point coordinates are -1, -1, -1. For point 2, coordinates are for 0 for x, -1/2 for y, and 0 for z. For point 3, these are -1, 0, 0. Now I have acquired all 3 point coordinates. What I will do is to go to online solver, plug in these values. So my points are -1, -1, and -1, and I will insert others. Zero, 0. Let me check. Find equation of the plane. So here, that's the equation of the plane. Let me write this down. So our equation is x plus 2y plus 2z minus 1 equals 0. When this plane intersects z-axis, at that point x and y coordinates will be 0. So I will plug in 0 for both of them and solve the equation. Z is equal to 1 over 2. So we have found intersection point. It is 1 over 2. At this point, we have found intersection points. Second rule, when we find Miller indices for the plane, after we take intersections, take reciprocal, so that 1 over negative 1, 1 over negative half, 1 over positive half. It will be negative 1, negative 2, positive 2. Enclose it in bracket, and this caps indicates that these points are negative. That's it. Let's move on. For plane 2, here I don't need to change the origin, and I will keep axis system. This plane, as you see, does not intersect x-axis. If you see, these two lines of the plane are parallel to x-axis, so they will never intersect. Infinity, y-axis. Plane intersects y-axis here, which is 1 over 3, intersects z-axis at point 1. Take reciprocal. It will be 0, 3, 1, and enclose in a bracket. That's it. For this one, here, this is the origin, but I cannot use it because if you see, this plane actually intersects y-axis at half, but if I choose this point as an origin, this is y-axis and they don't intersect. So that's why I have to choose such an origin that I'll have intersection. So if you see, this plane is kind of inclined or gathered around this point of the cube, this part of the cube. So my origin will be somewhere there. Now let's see. If I choose this one as an origin and draw intersection points, axis system, it will be positive y, positive x, and negative z-axis. So here, if you see, plane intersects y-axis at 1 over 2, plane intersects z-axis at negative 1 over 2, and it's parallel to x-axis. You see again, this plane lines are parallel to x-axis. So x, y, z. Plane does not intersect x-axis, infinity. For y-axis, 1 over 2. For z-axis, negative 1 over 2. Actually, we could have chosen this point as an origin 2. It will be correct 2. It doesn't matter. So 2 origins, we can choose one of them. So step 2, take reciprocal. It will be 0, 2, negative 2, and enclose in a bracket. Next. For this plane, again, if you see, this triangular plane is like gathered around this point over here. So it will be my origin. Draw axis system, negative x, negative y, negative z, x, y, z. Plane intersects x-axis at negative 2 over 3, y-axis at negative 1 over 2, z negative 3 over 4. Take reciprocal. It will be now I have to get rid of these partial values. I need to get integers, so I will multiply by 6. It will be negative 9, negative 12, negative 8. Enclosed in a bracket. That's it. Next, for this plane, again, first I will change the origin. That's previous origin, but if you see this plane is away from it, this plane is inclined on this side and it's kind of comes toward this point over here. This will be origin, this point, and axis system will be negative y, negative x, and positive z. So this plane intersects y-axis at negative 1 over 2, z-axis at 3 over 4. For x-axis, it's not clearly seen here, but if you see, this plane goes outside of the cube and somewhere outside intersects negative x-axis. In order to find it, what I will do, I will take only this side of the cube and draw it over here. This is z-axis and this one is negative x-axis, but for now I will take everything positive and later will compensate for negative sign. This is 3 over 4 point, this one 1 over 2. So this line comes like this and somewhere intersects x-axis. I need to find this point. This is a straight line, so if I find equation for this line and later find intersection point, I can solve it. So this point is 0 origin, so this is 0, this is point 1. I am taking everything positive for now. So what's the slope of this line? First, this will be my equation. I need to find this slope, a. So it will be, let me write this one. This is length 1, and this is over here will be 3 over 4 minus 1 over 2. 1 over 4. The slope will be 1 over 4 divided by 1, so 1 over 4. That's the slope of the line, and it goes down. That means I will have a negative slope, negative 1 over 4 x plus. This line does not start from the origin, it starts from 3 over 4. So that's the equation for the line. If you want, you can use online solver. So here, I know that when this line intersects x-axis, z will be 0. So plug in 0 and solve the equation. X is equal to 3. So 3 over here, I am on negative x-axis, it is negative 3. So far, I have found all intersection points. Take reciprocal. It will be 1 over 3 negative, negative 2, 4 over 3, multiply by 3 to make them integer. It will be negative 1, negative 6, and 4, and enclosed in a bracket I'll write it down here. That's it. Now for this one, I will choose this point as an origin because I see that if I draw axis system, this is positive y which intersects plane at 1/2. This one positive x where intersects plane at point 1, and positive z-axis because if I extend that plane outside of the cube like this, I see that this intersects somewhere here. So this z-axis comes, intersects plane and goes outside. So, and as a result, I see that I have chosen the right origin. Now for x, y, and z, for x, intersection point is 1, for y, 1/2, and for z, tricky one is to find z. Again, I need to get equation for the plane. This plane has 3 points, 1, 2, 3, and point coordinates for them will be, this is origin, 4.1. If I move positive 1 in x, positive 1 in y, negative 1 in z, I'm there. So 1, 1, negative 1 are the point coordinates of point 1. For point 2, if I move positive 1 in x, so it is enough, I am there. For point 2, x is 0, 1/2. For y and 0. I have found these values when this point is origin. So for these values, I will find plane of the equation using online calculator. So equation is this. This one over here. So let's move on. My equation is x plus 2y plus 2z plus 1 equal 0. I know that when this plane intersects z-axis, at that point x and y will be 0. So plug in 0 and solve. Sorry, if it was plus 1 or negative 1. It is negative 1. Sorry, it is minus 1. This one is minus. One over 2. So this plane intersects z-axis at 1/2. Now I have my projections or intersections. Take reciprocal. It will be 1, 2, 2. Enclose in a bracket. That's it. Next. Now for this one, Miller indices are given and I have to draw planes. So it is complete opposite one. In order to do this, over here. For first one, First, open the bracket, take reciprocal, it will be and which equals to negative half, 1, and infinity. So this plane should intersect x-axis at negative 1 over 2. So this is positive x. I am moving back. Negative 1 over 2 is somewhere here. Mark the point. Plane should intersect y-axis at point 1, which is here. Mark the point. Now this plane should be parallel to z-axis because it is infinity. I have acquired these 2 points, so connect them. Because plane is parallel to z, I will extend this plane, this line parallel to z-axis. So draw parallel line to z. This is the plane which I need. That's it. If it is for you difficult for you to understand how this thing looks like, let me do this. I will erase ink over here. Okay. So that's it. So this plane is totally outside of the cube. Shares this, but shares this line over here. Now let's move on to second one. This is if you see I don't have a 0 over here. That means it will be triangular plane. So again, first open bracket, negative 9, negative 4, negative 6. Take reciprocal. Now all are negative, so this plane should intersect x-axis at negative 1 over 9. Let's say somewhere here. I am taking approximate lengths. So point 1, plane intersects y-axis at negative 1 over 4, somewhere here, and z-axis at negative 1 over 6. Here. I will connect the points. So that's a plane totally outside of the cube. Let's say, in order to make it easy to see, let's do this. I will change origin so that this plane will be inside of the cube. To make it easy to understand, I see that all are negative. So if I choose this point as an origin, all these points will be inside of the cube. So here, negative 1 over 9, let's say this point, 1 over negative 4 here, 1 over 6 negative here. And if I draw this plane again, Okay. That's it. That's a plane we were searching for, but I have changed the origin. That's the only difference. You can do this in exam or in assignments. That's the same plane. For this third one, 0, 2, and -3. Again, open bracket, take reciprocal, sorry, so take reciprocal, it will be infinity, it will be infinity 1/2 and sorry, yes, 1/2 and -1/3. So this time, what I will do, this plane should not intersect x-axis, and z is negative. That I will choose this point as an origin, but this time I will change axis system. So I will say that this is negative z-axis. So plane intersects y-axis at 1/2 over here, z-axis at -1/3 here. I will connect these 2 points, and I know that this plane should be parallel to x, so I will extrude this line parallel to x. So I will draw 2 parallel lines to x and connect end points. So that's it. That's required plane. So what we can do, we can draw something like this, which is outside of the cube. I can change origin like I did in second one and draw plane, or we can keep origin but change axis system. So all are correct because that's infinite space. You can rotate orientations and cubes. That's it. Thanks.